This is question 5 in the Assess of Chapter 8 on page 116. Now, it says the area of a rectangle is y meters squares. Let's draw a quick rectangle here. So if the area is y meters squares, that's inside there like that. And so we're told that the length of the rectangle is 1 meter greater than its width. So let's say the width is x, then the length is going to be x plus 1 because it's 1 meter greater than the width. So there we are. Let's form an equation. Well, the equation is going to be y equals x multiplied by x plus 1. Be good enough. Don't have to multiply out, but we can if you want to. So let's just do that. That'll be x squared plus x. So that's the formula. So y equals x squared plus x, and that's the area of the rectangle of area y. Use values of x from 0 to 5 and draw a graph. Okay, well, let's just do it down here, the usual thing. We'll have x values from 0 to 5, and the y values will be represented by the calculation x squared plus x. Usual thing, do this sort of thing, like that. Hopefully there'll be space to the graph in this corner here. I'd like to do that anyway. So 0, 1, 2, 3, 4, 5. This will be in meters because we have meters squares in the area and meters as part of the length of the rectangle. So if you obviously put 0 in there, you have no length, you have no area. 1 times 1 is 1 plus 1 is 2. 2 squared is 4 plus 2 is 6. 3 squared is 9 plus 3 is 12. 4 squared is 16 plus 4 is 20. 5 squared is 25 plus 5 is 30. So I've now got to try and plot these little points. It's quite easy really. I won't go higher than 30, so let's just do a quick little graph here. Hopefully that'll be perfect. Put it about there somewhere. If I begin to do the scale, then I know how far to take it. If we call that 30, what should we do? 2, 4, 6, 8, 10. So we can call that 20. 2, 4, 6, 8, 10. We call that 10. And 2, 4, 6, 8, 10. We'll call that 0. Therefore, that's the scale I'm going to play with. Let's extend this little line down here. Bam, there you go. Going up in 2s along my y-axis, which is in fact my area axis. And then we'll go across here 1 to 5. Let's just put a nice line there. And what I won't use, I just simply won't use it. So that's 0, 1, 2, 3, 4, 5. So this side's going to be the x value, that direction, and that's y in that direction there, arrow, so that's y. And y is in fact the area, so this is the area in meters squares, and this x is going to be the width, and that's measured in meters. Hopefully you can see that, and my face won't be in the way of that. But if you can't see it, where I'm operating here in this place, then that is the width of the rectangle. So we're going to get plotting straight away. 0, 0, very, very easy. Let's just go for another colour. 0, 0, 1, 2, 2, 4, 6, so that's there. 2, 6, that's going to be there. 3, 12, it's going to be there. 4, 20, there. And 5, 30, oops, right there, I've crashed into my equation. Let's try and draw a lovely straight line graph. Well, no, sorry, it's a curve, obviously, not a straight line. Start about here. Try and be nice and careful. It's quite difficult doing this. Right, I'm happy enough with that. Right, so that's that. I've drawn myself a graph, and I'm showing you what's happened to the area as the width changes. Now, find the values. Yeah, done it. Draw a graph showing what happens to the area as the width changes. Well, okay, I'm changing my width. I've obviously got an x squared type graph. Obviously, it's only positive values because we only have positive values of x for width. Now, what is the width when the area is 10 meters squared? Let's show the examiner what our brain's doing. Let's take this 10 meters square. So grab the 10 meter square area, hit your line, come straight down. I make that 2.7 meters. Again, label carefully across and down. So that's 2.7 from my careful reading. Next one, what is the area when the length is 4.5 meters? 4.5 meters, so 4.5 is there. Hit the line, turn left. Ooh, it's a nice one. 22,468, 22. Lovely. So this time we're reading up and turning left, 22, 24. So that's 24 meters squared. Find the length when the area is 4 meters square. Right. The length this time. In other words, work out the x, then add 1 onto it. Okay? So let's just go back to this. 4 meters squared is here. No, sorry, I've misread the question. Sorry. Find the length when the area is only 4 meters square. Okay, so this is the area. So 2, 4, hit that, and then come down. Right, I'll make that 1.4 meters the width. So therefore, the length is going to be 1.4 plus 1. So that's going to be 1.4 plus the 1, which equals 2.4 meters. And that's what I'm quite happy with. Alright.